That's close enough. Let's take a look at these. So in this problem, this is number 2 on there. This was the tell me part. And then they asked me, what did they ask me about? Yeah, volume. What's the volume of this? Just from what I've drawn. X squared h. And I want volume as a function of x alone, so I need to get h as a function of x so I can replace h. I can eliminate h by substituting a function of x in place of h. And I can get that function of x from here. Divide everything here by 2. Subtract x squared, divide by 2x. I get h, 500 minus x squared, all over 2x. Is that cool? All right, and then I just plug that sucker back in here. So I get volume as a function of x alone. So volume will be, multiply x squared times that, one of the x's dies. So then everybody up top just picks up an x. Is that cool? Yes, sir.
So when looking at these types of problems, you're not necessarily looking for an answer, you're just finding the
No.
function.
I want you to realize this is a preliminary worksheet for the basic skills you need to even start to do the calculus that's in 4.7.
Okay.
This is not calculus at all yet. This is just the first step.
Yeah, because we weren't necessarily solving for anything.
Yeah, the next step, I'm actually going to do one of these problems, going to create the next step. I'll show you. In fact, maybe it's going to be this one. Yes?
Even though it's the same thing, do you prefer it written out as you did, or 250 minus x cubed over 2?
Oh, it doesn't matter. Yeah, you can write this as 250, I like it, x minus 1/2 x cubed, which makes sense for the next thing I have to do. Well, that's the end of that one, right? Now, what I would say next would be the calculus step, which is where I'd say, find the maximum volume for the situation. What's the biggest the volume could be? There is a maximum volume. So there's a limitation on the material used. That's why the volume has to have a maximum. I can't just make it as big as I want to because I can only use 1,000 whatever second. Does that make sense by itself? That's why the next step would be the true optimization step. Now back in like algebra and precalculus, you found the vertex of a parabola. Most of your equations had to come out to be quadratic because then the max or the min would just be at the vertex. You don't need any calculus. Right? Do you remember that at all? Optimization problems in pre-calc. Find the maximum area of this. You would get a parabola, quadratic, and you would find the vertex. Does anybody remember the side note here? Does anybody remember the shortcut for the vertex from something of this form? Okay. Does anybody remember quadratic formula? Yes. Now, if I told you the intercepts of a parabola were here and here, where would the vertex have to be? Right in the middle. I love it. That finds the intercepts of that parabola. What is right in the middle of negative b over 2a plus this and negative b over 2a minus this? Freaking negative b over 2a. That was the shortcut to find the x part of the vertex. X equals negative b over 2a. You guys remember that? Now we can do calculus on this shit. What's f prime? 2ax plus b. And where will the vertex occur? Be it a max or a min, it will occur where the slope is 0. And if you solve for freaking x, negative b over freaking 2a. Much freaking easier than freaking out. Right, so that's nice. But it's still, I mean, it makes beautiful sense up here. It's going to be between the two. Well, negative b over 2a is by definition between the two values because it's plus this shit and minus this shit. So of course it's in the middle. But then calculus comes along and says, that's nice, look at me, right? I did it in one step. All right, so hopefully the negative e over t is a little bit, but now calculus, now we're able to handle anything. It doesn't just have to be a parabola. I can find the min and the max of any damn thing using the calculus, right? So here, this function is not parabolic, but how would I find the extrema for that volume? I mean, I'm adding another step onto this problem. This would be the calculus step.
First derivative is 0.
Yeah, take the derivative of v and set it equal to 0. All right, so v we got here was 250x minus 1/2 x cubed. What's v prime? 250 minus 3/2 x squared, right? Comes down, goes down by 1. And I would do what with that? To find the max or the min, I set it equal to 0. Let's get my critical numbers. So I get 3/2 x squared equals 250. Double it, divide it by 3, take a square root. I'm going to eliminate the negative option because it's a freaking box. Can't say you want it negative 3 feet by, wait a minute. What does that tell you? It tells me the
X value.
yeah, it's the size of the square base, the length of the square base, that gives me the biggest volume. What would the height be in this case? Yeah, I love it. So we have the freaking, now we know what x is, I can just plug it in there. Now, to be honest, I'm hoping it's somebody out there. If you plug that in and you do the work, you get that h equals that. Because, of course, the optimal shape for a rectangular box is actually a cube. That is the optimal shape. So, of course, I'm going to get the h equals the same thing as x. So it truly is a cube then, right? If you don't trust me, put that in there. Work it out like you should be able to, and then you will get that it equals the same thing. In fact, if I say any rectangle has a perimeter of any damn thing, what maximizes the area? It's going to be the square. Period. So let's finish this out, and then I'll do it a problem where the answer is not a square, because they have an extra fence in the middle. Right. So that's number 2. For number 2, as far as you had to go was this. That's all that number 2 wanted. I did some extra calculus shit just to show you what 4/7 is going to look like. It's just really one more step. Funny thing is, that step is going to be the easy step. What about number 3? That should have been decently straightforward. What do they tell you? In number 3, what do they tell you?
Height equals 3D.
Yeah, height is 3D. And of course, I don't want diameter, I want radius. So height is 6r, because d is 2r. I like it. And then it says, write the volume of the, so they tell me this, and they ask me something about the volume of the cylinder. I give you the volume of the cylinder there. They want me to write that as a function of h only. So what letter do I want this solved for then? R. So I can rewrite R in terms of h. I want h to be the survivor. I don't want to plug 6r in for h, because then R is the survivor. I don't want volume as a function of radius. I said volume as a function of height. So here R is h over 6. Throw that bad boy in there. And I end up with pi over 36 times h cubed. Cube should make sense. It's supposed to be volume. I like it. Well, this is purely an exercise in writing as a function of something. There's no restrictions on this, so it wouldn't really be a calculus problem. Is everybody cool with this one? Volume is a function of height. If I said volume is a function of radius, you would have just plugged 6r in for h. You got it directly there? Okay. What about the 4th one? That's the one I gave you a few little notes Where'd it go? So the volume, of course, here was pi r squared h again. And the surface area, and they tell me the volume is 60. Tell me this, and they ask me about the surface area. Now, real quick, why does it make sense the surface area of a cylinder is the formula I give you? Well, how many circles are there? Two. And they're both pi r squared. So you know there's going to be a 2r squared, 2 pi r squared in there. I can't remember what order I put it in. Doesn't matter. Now here's the cool part. And the book does this, of course. They have computers doing all their pictures, so of course it's nice. But think about it like a Campbell soup can. You cut the label off for some kind of send-in, whatever the hell. The way they used to do it. If you cut, chop, 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 and then you unroll it. Well, how long around is this? Huh?
2 pi.
2 pi r. I like it. And how tall is it? H. So if I unravel that and put it flat, it'll make a rectangle. Right? A cylinder is just a rectangle that's been folded to meet at the edges. So this will become a rectangle that is h tall and 2 pi r wide. So what is the area of this? So there's where the 2 pi r h comes from. I love that idea. Real quick little side note. Have you guys ever seen the proof of the area of a circle? No? All right, I'll show it to you later. Maybe. Or maybe not. Where'd it go? So now, how can I use what they tell me in what they ask me? They want surface area as a function of only radius. So I want to get rid of h. So I want to take this and solve for h. So from this, what is h equal to?
60 over pi r squared.
Why did I do? Okay. So 60 over pi r squared. Okay, I'm silly. Where'd it go? Oh, that equals h. Right there. And now I can plug that in for h. So now I get surface area is 2 pi r squared plus 2 pi r times 60 over pi r squared. Now what happens there? 2 pi r squared plus pi dies, 1 r dies, 120 over r. Now here again, I could ask you to maximize, and actually in this case it would be minimize the surface area. Because I tell you the volume, so there's some minimum surface area needed for that. It's kind of like the opposite of the one we just did. So you take the derivative, get it equal to 0, go from there. Let's do it. What's this guy's derivative with respect to r? 4 pi r? Yeah, this would be r negative 1, so it would be minus 120 over r squared. Set that equal to 0 and solve it for me. you set it equal to 0, you can add that part over. Divide by 4 pi, multiply by r squared. And the last thing is just to take a cube root. What's the height? Well, what's the only thing we really know about the height?
That's times 6.
That's gross. So the height would be 60 over pi times this thing, the 1/3 squared, so the 2/3.
Doesn't it say, like, sorry, in the beginning of the problem, it just says the height is 3 times the diameter, so could you use that to figure out?
Oh, yeah. I forgot I said that. Was that this one? Wait, that was number 3.
Oh, okay.
Yeah, sorry. I was like, wait a minute. Yeah, unfortunately, that's the only way to do this one. Yeah, you can throw all that in the calculator, or I might ask for an exact answer that's simplified a bit. Let me show you guys something. Do you see how there's a radical in the bottom? And it normally involves rationalization and stuff, right? Do you see how height is 60 over pi r squared? Why does that suck? Because I know what r cubed is. R squared is shit, right? So let me just do this. So at least the bottom's nice. I can just put r cubed, 30 over pi goes right there, and the pi's cancel, and 30 goes into 60. Do you guys see that? So this will be 60 times shit over pi times nas. That's nas. 30, oh gotcha. I'm not gonna do that. That's a hell of a lot better than dealing with that shit, right? Of course, some of you guys hopefully would realize you just multiply top and bottom by 1/3 of this, and you get to the same place I was anyway. But still, I'll send you a little trick. And again, what did I just do? I just showed you a little bit of flexibility that you didn't even know you had. I know r is not 0, so I'm allowed to multiply that. Why did I do that? Because I know what r cubed is. But I don't know what r squared is. So let me introduce r cubed. If you don't like this, just do it this way. That's fine. Do it this way. I'm just showing some of you guys a little bit more flexibility. Okay, so let's do this. Let's do a few problems right out of 4.7. So you see what a full-blown calculus optimization problem looks like. We'll do a few problems out of 4.7, and then we'll see what time it is. Oh, I'm going to do this problem. What I was talking about. What did I say to myself? I said to myself, we have 80 meters of fencing to use. We want to use all of it to make this shape, right? I want to put my little hobbits here, my orcs there, and I need it walled off so that they don't eat each other or drop each other in Mordor or whatever, right? Or, whatever other animals you want to put in there. Of course, that's kind of hobbitist. I call them all animals. Oh well, I'll tweet that tomorrow. So what right there, what could I write down? I haven't even asked the question yet, but what could I write down from that? I was really nice. I labeled all this stuff for you, right? Almost all of it. Yeah, 3 x's plus 2 y's equals 8. So this is what they tell me. And now I want to know the maximum area that I could create. I want the most area for my little hobbits and orcs to play in. What's the biggest area I can make? Because I can make this. I can make this. Right. They don't have much area. Oh, God. Can't even turn around. Right? Like flopping the. So I probably don't want to do that to them. I want to give them the biggest areas to play around in, right? Using that much fencing because that's how much I got, and I don't feel like buying any more. So now, what's the formula for what they ask me? What's the area of this? XY, beautiful. Don't overthink it. Now, be careful. I mean, I remember this guy in the back, specifically one semester, very early when I was teaching, a student in the back we cut a piece of wood. The wood was 10 feet long. I cut it in 2 parts, where one part was twice the size of the other one. Is this, right? You've seen a million word problems like that. Guy in the back was like, well, Mr. Wall, if you saw a piece of wood, you lose 1/4 in the teeth of the saw. I'm like, you can put that in your word problem if you want to. The rest of it is using lasers, all right? The rest of it is... That is a good point. I mean, what we do in here very often is idealized. And then the real world throws little adjustment variables at us. So there's a whole course called Perturbation Theory about you start with the ideal and you start perturbing it with reality, right? So in physics, you have these frictionless tables that I want to know where I can buy those, and the massless ropes. And then later you learn, oh, what if the rope isn't 0, like most of them are, How do I change what we already did? But I have to have a starting point. Okay. So yes, there is a width to this fence. Yes, the area won't be exactly x times y. But we're going to ignore that for now. We're going to deal with the ideal situation. You guys with me? I like it. Some of you guys are like, I didn't even think about that shit. So the area here is definitely xy. Who cares that that's down the middle? Area doesn't give a shit what's happening on the inside. He just cares about covering. And of course, how do I use what they tell me and what they ask me? How do I use what they tell me in what they ask me? Take this and solve for, it doesn't matter. Solve for y. Sure. So y equals 80 minus 3x over 2. Is that cool? Or 40 minus 3/2 x. Solve for a letter and then plug that in. So here's what they tell me in a more useful form. Let me plug that in. So now I get area is x times 40 minus 3/2 x. So area is 40x minus 3/2 x squared. So now that I got my area as a function of a single variable, what can I do to this thing to help me figure out the max? Yes, take the derivative, set it equal to 0, because that's the location of a possible max, right? So A prime would just be 40 minus 3x. Power goes down by 1. Set that equal to 0. And you get x is 40/3. Now if x is 40/3, what's y? 40 minus 3/2 together. 40/3. The 3's cancel. 40 divided by 2 is 20. 40 minus 20 is 20. Now watch. I claim that there's still a square to be found here. So each y is 20. Is that cool? So this is 20. So it's 20 by 40/3, right? how much total fence is going up and down? Going in the x direction. How much total fence? Total fencing. How much? What's the total length of the fencing that's running in this direction? 40. 3 40/3. 40. What's the total length of the fence running in this direction?
40.
So in a sense, it's still 40 by 40. It's still a square. I don't know if anybody gets what I'm saying. It's kind of neat. It's still a square. It's neat. Now some of you guys are like, there's no square there. I'm with you. I'm with you. You don't need to understand what I just said, but I know that it's really neat. What I like to do on a test is to say they construct this side out of a special material costing $5 a foot, and they construct the rest of all the sides from material costing, $3 a foot. What's the minimum cost for constructing this? Even then, I like to show people it comes out like a square. The cost in this direction is the same as the cost in this direction total. It's neat. Some of you guys are like, shit. Oh well. Let's try another one. Let's try one right out of the book. That was one from me, but it's exactly like what the book would ask you. Let me take one right out of the book. Some of these are kind of dumb, like find two positive numbers whose product is 100 and whose sum is a minimum. You want to try that one?
Yeah.
All right, two positive numbers whose product is 100. Write that down. Write down the formula for that. And whose sum is a minimum. Is a minimum. The sum of the two numbers is a minimum. The sum is a minimum. That's what they asked you. There's two numbers. What are they?
X and Y.
X and Y. All right, X and Y. What do they tell me? The product is 100. And what do they ask me? The sum is... The sum is? No, the sum is X plus Y. And I want to minimize that sum. So when you write down what they ask you, it's a function. And then I'm going to do shit to it. So what do they ask me about? The sum. I love you guys. So the tell me is a function, and the ask me is a function, right? What do I do with the ask me function? Well, I got to use what they tell me to help me with what they ask me. What do I do with this? Solve for a variable, so I can plug it in here so I don't have too many variables in the thing that I'm trying to work with. I want to take this guy's derivative, but we don't know about partials yet. That's later. There's a thing called partial derivatives. So let's not do that shit. Let's get a single variable so that I can do normal calculus to it. So what do you want to solve for? I don't care. X. Sure. Change things up. So know that X is 100 over Y. So that, so you see how I gave the function a name? I call it the sum function because that's what it does. So I'm going to just use the letter S. The sum is X plus, oh, get out of there, X. The sum is 100 over Y plus Y. So that's, all that was building the function that I'm going to work with. And now to minimize or maximize it, that's calculus. Minimize or maximize is going to be where the horizontal tangent line happens. Now I'm not even getting into the whole, nobody's asked me this yet, so I'm just trying to stay basic for a while. How do you know it's an actual max or a min instead of a resting point or the wrong thing, right? Minimize our cost, Johnson. Yes, sir. You maximized our cost, Johnson. You're fired. I'm sorry, sir. I found the horizontal tangent. Right? I mean, you understand what I'm saying? There's another layer to this that I'm not even going to get into yet, just so we can get this shit down. So what's the derivative of this?
1 plus, or 1 minus 100 over.
Yeah, 1. I like it. And this is 100y to the negative 1, so the derivative would be negative 100y to the negative 2. And then what do you want to do with that? Set it equal to 0 to find the horizontal tangent line locations. So then, of course, multiply by y squared. So y squared minus 100, which kicks ass. So y equals Yeah, why? And I eliminate the negative 10 option because they said positive integers, but they said that. So y is 10, and therefore x is also 10, which is related to a square is the answer to the basic questions. There are the two positive numbers whose product is 100 and whose sum is a maximum. Give me another set of positive numbers whose product is 100.
25.
Sum is a minimum, sorry. What? Say again?
25 and 4.
25 and 4. 25 and 4 multiplied to be 100. Is there some less than this? No. Because the prompt said make the sum a minimum, right? So this sum is 20, that sum is 29. Any other two numbers you come up with that multiply to be 100 that are positive will have a sum that's more than this, more than 20. Because we just figured out that's the one that makes the sum a minimum. That's what we just figured out. How do I know it's a minimum? Because, well, basically I just proved it. I picked another pair and it was bigger than this. So this must be the minimum. This is the only critical point. So this must be a minimum because somewhere else was higher than it. Right? That's one way to check to see did I find the actual min or max or what. Okay. Let's do one that's a little more geometric. Well, let's try one like this. Where is it? Where is it? Where is it? Ooh, there, here we go. I like it. That's what's scary. Let me say that. So, this one says, find the points on the ellipse. 4x squared plus y equals 4. Find the points on this ellipse that are the farthest away from the point 1, 0. So you can see how this is some set point in space, and this is the equation governing the motion of the Earth around the sun, and we want to know when are we the furthest away from this spot. It sounds like a possible thing to figure out, right? It's kind of related to this. All right. So they tell me this, obviously. They tell me my points that I'm working with lie on this ellipse. Do you see how this is a... Oh, shit. There you go, Jeff. Do you see how that's a relationship between x and y? And then they ask me, I need to know which points are the furthest away from this. Furthest away from that point. So what's the function that I'm trying to, in this case, maximize to make it the farthest? What's the function I'm dealing with? Distance. I love it. And what is the distance function for 2 points? Let's call them x1, y1, and x2, y2. Yeah, the square root of x2 minus x1 squared plus. This is just Pythagorean theorem. Right? Okay, so if the point, so this is what I'm trying to, and now watch. If you realize what's going to happen, we're going to have to take a derivative of this. Thank God I'm allowed to do this. Let me not use the distance function. Let me use the distance squared function. Because if I can make the distance, the square of the distance minimum, or maximum, that means that this is going to be maximum also. If my square root is over every damn thing, and I got to take a derivative, that's the chain rule with ugly shit all over the damn place. I'm allowed to minimize, or maximize in this case, the inside, because wouldn't that maximize the square root of that? If I want to maximize the square root of a number, and I make this number as big as it can be, doesn't that make the square root of that the biggest it can be? Okay. If I want to maximize this, and I make this as big as it can be, doesn't that make the square root of it as big as it could be? Yes. Okay, good. We're all there. So thank God I'm trying to help you so you don't have to take the derivative of something really disgusting. It's still going to be kind of gross, to be honest. Not as bad as it could be.
So if we were looking for the closest distance, would we keep it in the square root form? If we're looking for the minimum?
No, we wouldn't. No. It depends on the setup. It depends on the restrictions they use. There could be other ones asking for the minimum, and I would still do it the same way.
Okay.
It's just the restrictions here are my point has to be on this function. The restriction could be something different for another problem. So even if it's a minimum distance, it's going to be the same idea.
Alright, so,
yes.
and it all depends on the point.
It all depends on the restriction, how they set it up.
Does a minimum make sense on an ellipsis like that if we're trying to find the distance because it would be the same on both directions? Is it you're saying the farthest distance, so it makes it so that there's one point where they're the farthest away from each other, right? So wouldn't the minimum be like the two closest to the point? Is there no such thing as a minimum? I don't know if I'm just misunderstanding.
There would
In
be.
this scenario.
Well, all right. So if I have an ellipse and have a point, there's obviously a closest point, right? But depending on where that point is, let's see, 1, 0. 1, 0 is on that ellipse. Isn't 1, 0 on the ellipse? Right? So now I'm saying if it's here, then I want to know what's the furthest point from that. In which there could actually be two that are on the ellipse that are furthest away from it, because of the squashed nature of the ellipse. All right. So if they had one that was off the ellipse, then they might ask for what's the point on the ellipse that's the minimum distance. Now, if I said what's the point on the ellipse that's the minimum distance from that, the answer would be that. Done. Please, Jeff, let that be true about problem no. These are not the problems you will get. Okay, so now watch. Let me just do a little bit of work here, believe it or not, before I go back to what they told me. What goes in? Let's say that my x1, y1 is the 1, 0. So that would be x2 minus 1 plus y2 minus 0. Okay, so let me bring this up here. The reason I'm doing that is it helps me figure out the smart thing to solve for from what they tell me. So again, let me write it again. They tell me this relationship, and they ask me something about this guy here. Where'd he go? All right, here's what it looks like now. x2 minus 1 squared plus y2 minus 0 squared. So of course that's just x2 minus 1 squared plus y2 squared. So what do I want to solve for from here? Y. I actually don't want to solve for y. I want to solve for y squared because, bam! Here I have to solve for x. Unless they multiply. Even if I multiply it out, there's still going to be an x in the middle. Do you guys see? I don't want to solve this stupid thing for y or x, do I? Why? Because the freaking square root comes in. And I got to take a derivative later. What the shit? But it's still going to work if I do it that way. You could do it that way if you want. It's still going to work. Calculus doesn't give a shit how much work you got to do to get the answer. But I'm going to do the way, hey, I can just solve for y squared because there's a place for it. There's a place for it. So if I solve this, what do I get if I solve this for y squared? I get y squared is 4 minus 4x squared. So use what they told me in what they asked me. So put in the other point. What's the point on the ellipse? The xy point. Well, whatever x is, the y is going to be this. Y squared is going to be this. So I can just put those in. Now here's what now please, dear God, you're not going to do implicit differentiation. This is the d squared function, right? I don't know if this really makes sense to you guys, but if I maximize d squared, then obviously I've maximized d. So there's no implicit shit here. I know it's a square. I'm just going to, what's the derivative of this function? I left this like this because it's easy. I don't like to FOIL this shit out because the derivative is easy. 2 comes down in front of this. Done.
Is it minus 4x squared?
Yeah.
What is it? Oh, 4. Thank you. I left the portal 4 out. I don't know why I thought it was. Okay. And then keep going. What do you get here? That, of course, goes away. This is taking derivative. Minus 8x. Okay. And, of course, you could FOIL this out. You get x squared minus 2x plus 1. Derivative of that is 2x minus 2, which is the same thing I just got. So I want to set this equal to 0. See how this shit doesn't matter worth anything, because whatever I get, I'm going to set it equal to 0 to get the horizontal tangent line. It doesn't matter what you call this. So here I get negative 6x. Where am I at? 2x minus 8 is negative 6x equals 2, right? So x is negative 1/3. Is that right? And now, why does it say find the points, plural? Because when you plug x equal negative 1/3 in, and you solve for y, you're going to get a plus or minus. You're going to get 2 possible y values. Sweet. I love it. So now you just plug in negative 1/3, you get 4 times 1/9 plus y squared equals 4. Subtract that, take a square root, get a plus or minus. There's your 2 points. So yes, 4-7 is what you have supposedly been getting ready for since Math 90, really, or that level, is setting up the model of a word problem and then doing shit to the stuff, right? You translate from English to Mathish, so then you can do shit to the Mathish stuff, right? That's what word problem's first step is. You don't care about the math, you just say, who are the players? Bobby and Billy, and Bobby makes twice as much as Billy, so I'm going to say Billy's X and Bobby's 2X, and now what do I do with that shit? They make a total of 3,000. Okay, so 2x plus x is 3,000, and then I can do something. Now we're going to talk about minimum, maximum. So the first step is still going to be the same, and now I'm going to start taking derivatives of what I get to. That's the difference. That's the calculus step. The first step is the same as Math 90, Math 110, Math 176, or whatever you took for pre-calc. Let's see. You want to do one more, and then we'll call it a day? One more type. Let me see if I can find like a general type. Well, I mean, the other type would be, the type that we did a lot of already. Let's do one that's a little bit freaky-delic. Ooh. Let me do one that's sort of like that. Oh, so number 21 and 22 say find the point on the line, blah, that is closest to the origin. So that would be minimizing the distance. You do it exactly the same way, though. Let me see if I can find one like that. Other one. Oh, here we go. I like it. Perfect. I might have assigned this one, but you guys won't mind that. You see problems that say this type of thing. Find the dimensions of the rectangle of largest area that can be inscribed in a circle of radius r. I like this. It always says the circle is not amused. Sorry. So there's a circle of radius r. What does it mean to inscribe a rectangle in here? What does that mean? Draw, so like this. I drew it. Inscribe technically means the corner should touch the circle, right? So it'd be one possibility. You can see how many possibilities there are. It could be tall, it could be skinny, it could be fat, whatever. So I just draw something just to get something going. You can tell that the radius I placed is good for a general radius for a circle, but there's a smarter place to put it related to the shape I'm working with. Or I could have oriented the shape differently, but I won't. Does anybody understand what I just said? So where should I put the R at?
The corner.
Yeah, because give me some dimensions of this rectangle. What's this? Just don't even, not in terms of R. Just give me, that's X. What's this? Y. Oh my God. And so they tell me this picture. This is the picture. This is what they tell me. I got to figure out what the hell it really tells me in terms of some kind of a function or something, or relationship between X and Y. That's really what I'm looking for, is a relationship between my two main variables. And what do they ask me? What did I say? I said, find the dimensions of the rectangle, largest area. So they asked me the area, x1. So I'm looking at trying to figure out what's the relationship between x and y, so I can replace one of them. That's the real idea. That's why I like to break it up into tell me, ask me, because you can write both of those things down and try to work off of each other. So if I orient the radius to be like this, that might be a little more useful, right? R is what type of thing here? Is it a constant? Is it a variable? Is it the circle of radius R was given to me, so R is a constant. Can I change it? No, it's given to me. Here's the circle of radius R. Now inscribe a rectangle and make it big. Okay, shit. So, yes, I know R is not a number, but R is some constant. They just decided not to give it a numerical value. Too bad for us. All right, so what can you do with what I've drawn? Can you do anything with what I've drawn? Or is it complete shit? I don't know. I've just made a bunch of little rectangles, right? Is that useful at all? Do you know the angle size in here? No, it's a rectangle, so it could be anything, right? It can be to any angle we want to, depending on how skinny or fat. But isn't that a right triangle? You guys with me? I mean, that's when you're dealing with triangles, you look for right triangles because those are the nicest ones. You got trig, or you got Pythagorean theorem, hopefully. So, and this side, what's this side? One half x. And what's this side? 1/2 y. So sometimes you'll see books that say 2x, 2y, because they know ahead of time they don't want to deal with the fractions, which is an option. All right, but let's just go with this. So what relationship can I write between all that stuff?
So 1/2 x squared.
1/2 x all squared plus 1/2 y all squared equals. So this is what they really tell me. This is what they really tell me. Not very directly. Yes?
Can you just use like 2 of the triangles to make a bigger right triangle so you're not using halves?
So I see what you're saying. So like this guy comes in, but how do you know for sure that this hits it at a... Is that what you're saying? To make this big one? Oh, here, up here.
Yeah.
Oh, okay. Yeah, totally.
Then it has the c squared is
So then the hypotenuse would be
2r.
2r. This would be x, this would be y. Kick ass. I love it. Why not? So if you use that one instead, then what's the relationship? Let's see if it's really different. So this would be, oops. Yeah, that's right. This would be y and x. This is r. This would be 2r, right? So what's that say? X squared plus y squared equals? Yeah. But look here, what's this say? X squared over 4 plus y squared over 4 equals r squared. So x squared plus y squared equals 4r squared. Either way you do it. Right? I love it. But that's beautiful. Why not? Cool. I don't know if you guys picked up on this, but I didn't do this problem ahead of time. Right? So I'm going to do it like the first way I see it. Right? So totally, yes. If you have other ways you see, you can tell me, could I do it like this? Beautiful, I love it. I like to show you my thought process as I do problems. Now, at the same time, I know the most frustrating thing in any math course is that the teacher gets stuck somewhere and they're standing there for half an hour. I hated that all the time, but I'd much rather have that possibly happen than make it look like you're just supposed to know all this shit fluidly and it's beautiful because I've worked it all out ahead of time. So I like to do things. Anyway, either way you do it, you get to the same place. Now, what do I have to do with this, unfortunately? No, not set equal to 0. This is what they tell me, so I got to solve for one of the variables so I can plug it in to what they asked me, right? So if I get, like, if I solve for y squared, 4r squared minus x squared. So that means that y equals plus or minus, but why not plus or minus, of course, because y is a length. Yeah, so square root of 4r squared minus x squared. So that's what you plug in there. Now it's going to make a slightly more disgusting derivative. All right, you have that. So I get area equals x times y. And now I got to take this guy's derivative. I'll take a minute and do that. This will be the last problem we do, I think, by the way.
We have the 1/2 x squared plus 1/2
Yeah,
y squared. What is
I
that underneath?
did that
it?
very quickly. Square that, you get 1/4 x
Oh.
squared, 1/4 y squared, and when you multiply by 4, you get the same thing you got over here. Yeah. But I like that. This way you avoid all the halves. That's awesome.